Hi, I'm Alex and welcome to Module 3 of Fabric Fundamentals. In this module we're going to be discussing notebooks with Apache Spark. Now this can feel like an overwhelming subject as you do need to know some basic Python and SQL, but that's just it. You just need to know the basics, and Copilot can really help out with the coding as well. So let's get into it. Apache Spark is an open source framework for parallel processing of large scale data. It's widely used in big data scenarios for processing and analytics, and it's available on platforms like Azure HD Insight, Azure Synapse Analytics, and of course Microsoft Fabric. It enables ingestion, processing, and analysis of data within lakehouses, and core Spark techniques and code are consistent across platforms. Microsoft Fabric offers integrated tools for Spark-based workflows, a unified environment combining Spark and other data services, and it's easier to incorporate Spark in end-to-end analytics solutions. Spark pools are a cluster of compute nodes, and it's used for distributed data processing. So we've got two main types of nodes: the head node, which runs the driver program and coordinates distributed processing tasks. And then we've got the worker nodes that run the executor processes. So they perform the actual data processing tasks. The Spark pool configuration in Fabric, we can start off with the starter Spark pool, and that's by default. It enables Spark jobs, quick Spark job execution without the setup. And can be configured to optimize node settings based on workload requirements and cost constraints. With custom Spark pools, you can create custom Spark pools with tailored node configurations, and it's useful for specialized data processing needs. One pool can be set as the default for Spark jobs. So you can have a certain Spark job that is the default for a workspace. We can manage these in the admin portal. Go to the admin portal, workspace settings, capacity settings, and then data engineering or science settings. The key settings are the node family, so the type of VM that's used, so memory optimized for better performance. Auto scale, does it automatically adjust the node count based on demand? Or dynamic allocation, so adjust the executor processes on worker nodes based on data volume. The administrators can disable customization of Spark pools as well at the Fabric capacity level. Environments specify the Spark runtime version to use. We can view built-in libraries included in every environment. We can install public libraries from the Python package index, upload custom libraries by providing package files, assign a Spark pool to the environment for job execution, and set Spark configuration properties to override default behaviors. We can also upload resource files that should be available during Spark job execution. Optimization tips. So the native execution engine boosts performance for Parquet and Delta files. We can enable that via the environment or the notebook settings. High concurrency mode shares the Spark sessions across users and processes and improves resource efficiency with session isolation. Automatic ML flow logging logs ML experiments by default and can be disabled in the workspace settings. And Spark administration, the admins can manage and restrict Spark settings at the Fabric capacity level. Notebooks we've got interactive data exploration and analysis with Spark. We can combine text, images, and code in multiple languages. So we can use SQL and Python in the same notebook. Collaborative tools. Each notebook is made up of cells which can contain markdowns, so just a label of what the notebook does or what comes next, or executable code, so we want to run Spark or other supported languages from that cell. The code runs interactively and results are displayed immediately within the notebook. So within the notebook, we can select run all and run the notebook to completion, or we can pick each cell to run. We can also freeze cells that we don't want to run. Spark jobs. We can use Spark jobs for automated data ingestion and transformation tasks. Spark jobs can be triggered on demand or scheduled to run at specific times. To configure a Spark job, create a Spark job definition in your workspace, specify the script so that the job should execute, optionally include a reference file, and link to a specific lakehouse that contains the data that the script will process. Spark data frames. Use spark.read.load to load files into a data frame. Use magics to specify the language. So these here with percentages around are called magics, and they will tell the cell what language we're going to use, whether that's Pyspark or SQL. The inferred schema. Spark uses the header row and data types automatically. Explicit schema. This is useful when the file has no headers or for performance optimization. We can manipulate the data as required. .select, we can choose columns. .group by, we can group by those columns. And .count, we can provide a count of the rows. Saving a data frame in Spark, we can Spark allows saving transform data for future analysis, and Parquet format is commonly used due to its efficiency and compatibility with analytical tools. We can partition the data, and that will improve the performance by reducing the unnecessary data reads, and it's especially useful for large data sets with frequent filtering. We can read that data. We can load the data, the specific partitions, by targeting folders that match the partition values, and it supports flexible loading when it comes to the use of wildcards. Spark SQL. We can create temporary views from SQL queries for reuse in other parts of the notebook or workspace. We can save the current data frame as a table, and we can use Spark SQL API within any other coding language just by using the magic %% to turn the notebook cell into a SQL cell. And we can visualize the data within the notebook. So we've got built-in charting in notebooks. The Spark notebooks in Fabric can display query results as tables or charts, and charts can be customized using chart properties in the UI. It's useful for quick, intuitive visual summaries of the data. And we can use Python graphics libraries. So for advanced visualizations, we can use libraries like Matplotlib or Seaborn, and these libraries offer more control over formatting and styling. So on that, we'll move on to an exercise where we'll produce a notebook and we'll go through some visualizations and some little tips there. We'll be following a Microsoft Learn exercise, and I'll put the link to that exercise in the description so you can follow along. Right, so within this exercise, we've been provided some files. So I've followed the link and I've downloaded those files, and now we just need to add them into the lakehouse that we created in the previous module. If you deleted the lakehouse, just go through the creation again. Right, so within files, we want a new subfolder, and we're going to call this orders. Right, so in our orders, we want to just add the files. Now, usually we've got 3 dots there. I don't know why that's not coming up, but we're going to go get data and upload files. And here we have the 3 files that we need, and we can select all of those with Control and add them in, and just click Upload. Okay, now that we have the files, we want to go over to a notebook so that we can analyze the files directly. Rather than creating a table in the first instance, we're going to create the notebook and then look at the files there. If we open the notebook within the lakehouse, it'll automatically default to having that lakehouse as the data source. So we'll go open notebook and then new notebook from there. Fabric will automatically generate a name for the notebook, and it'll just be notebook 1, notebook 2, and so on. If we want to change the name to something a bit more readable, we'll go to the settings tab and then we can just change the name there, and we'll call this orders. Okay, now we need a basic understanding of Python, but what I'll do is I'll add a link in the description to a Pyspark SQL basics cheat sheet, and it's provided by datacamp.com. Really useful. I've got it in front of my PC at the moment. I've put it on the wall, and it's something that I use daily. So I'll pop the link down there, and that'll be helpful for you. Obviously, use Copilot as well to improve your coding. But what I'm not going to do in this video is just write through all of the code. So I will be copying and pasting from the exercise, and we'll just see what happens. So the first cell, we want to have it as a markdown, so we'll click that M with the arrow just in the top right, and you'll see that it'll change to just a definition here. If we want to edit that, click edit up in the right, and we want to change what that says. So I'll copy that from the exercise, paste it in, and you can see we've got our new markdown cell. Now that is just a statement within the notebook, and it's useful to tell people what's going to happen in the notebook, and you can add them throughout in between your code cells. So now we want to add a new code cell, and we want to start reading the files that we've got available in here. So we've got our orders, and if we click there, we can see the files. So over to the code, what we'll add is a cell that will start reading those files for us, and we'll press the play button to the side. Now it'll take a little bit longer to start with as you're loading up your Spark session, but then the cells will be quite quick after that. So we've got 14 seconds there, and all of our data's in. So what we're looking at here is the file 2019, and you can see with the display function we've got the table underneath. So now what we want to do is edit that for the column headers. So when we look at the column headers here, we can see that row values have been inserted, and we want to change that to the actual column headers. So if we create a new cell and add in that, so we've got dot option header is false, so we're saying there's no headers, so we need to insert some headers. If we just put underneath that display df, there you can see we've got column headers, but not very descriptive. So what we need to do is add a schema structure so we can define what those columns are going to be and what order we're going to have them in. And so I'll insert this code. Here we're importing the Pyspark library that we need, which is types. We're importing everything from there. And in that way we can use struct type and string type, integer type, and we can define what our columns are going to be called by using struct field and then the name and what type of column it is. Then we've got we're reading the file again, and then we'll display. And there you have it. So we've got our column names, and everything is structured as we would like to see it. So now we can modify this code. As we're looking at 2019 only, we want to look at all of our files. So we'll just swap out that 2019 for the wildcard. You can see we've got 2019 in the order date down here. But once we run that, we're bringing in all of the files and they're all appended. Here we go, and we can see 2021's in there. We've only got 1,000 rows, but you can see that's all appended. Right, so on to the next one. We want to start filtering this data frame, and with this code, we can create a customer's data frame where we can just pick out the customer name and the email column, and we can provide a count and a distinct count of the customers. And the next is we're going to be displaying the distinct count. So the print is just going to give us a couple of numbers up here, and then the display will show the table. You can see print has done its job, so we've got the count, and then we've got the distinct count, and then we've got visibility of the table underneath. Now we can change this this query. We can also use df.select, and we can swap out those brackets, those square brackets, and we run that, and we get the same query. So we've got the same results. Now, if we modify the first line of the code, so we've used the select. Now, as in usual SQL queries, we can also use a where statement, but it's just added on the end like this. Now, Python, it runs on one line. So, whereas with SQL we can keep on pressing return and just have a nice statement. In Python, that's not really the way it works unless we add a backslash at the end, a space backslash, and then we can start returning. When we run this, we should have it filtered to customers that have that item. So now we can see a reduced count. On to the next. So we're going to aggregate this with a group by. And I'll just copy this here because we're looking at product sales now. So we're selecting the item and the quantity columns, and we're grouping by item. And here we are saying, give us a sum of all of the results of that item. See, we've got the sum and the item. So the next statement that we're going to add is this, where we're importing a functions library so that we can use the order by, and we're going to do yearly sales. So we're going to pick the year of the order date, and we're going to call that year, group by the year, and then count. You can see a count for each year. Now the next cell that we're going to run is we're going to use data frame methods and functions to transform the data. Right, so let's add this cell, and here we've got transform data, where we've got it's what we did before, apart from we haven't got the order, and then we're going to add to that df. We're going to split down the username, so we've just got first name. We're going to split down the customer name, so we've got first name and then last name. We're going to split by the space, and then we're going to filter and reorder the columns, and we're just going to show the first 5 rows. So now you can see that we've got the sales order number, and we have first name and last name instead of the customer name. Now we want to save this transform data, and first of all we're going to save that into the as files. So let's add this cell. So we've got our df, so transform df, and we want to .write .mode, and the mode is going to be overwrite for this, and we're going to save as Parquet in this structure in files, transform data, orders. And we're also going to add a statement that tells us when the data has been saved. Okay, so now, we've got transform data has been saved, and now if we click the three dots on the files and say refresh, and if we open up transform data, we now have orders and we have the files saved there. So the next cell that we want to add is for an orders df, and here we're going to be loading the orders that we've just created. And there we have access to the file that we saved. Now we want to be saving data in partition files. So let's save this code. And I've previously done this exercise, so I've already got the partition data, but if that folder wasn't there, you would create it by running this code. So we've got partition by year, month, and partitioning is going to really improve the performance of your data. It's usually used in very large data sets, but if there's common filtering on year, month, customer, then you'll want to add partitions to your data once it's saved. So we'll run that. We're partitioning by year, month, and we're overwriting anything in the partition data. And again, we've just printed to say that the data's saved. Go to files, refresh, and there you go. In your partition data, you have folders that has split it off into the years and the months. So really useful to have that there. So with this, we've got add a new cell with the following code, and this is going to be where we're loading a specific folder from that from the partitions. So here we want to be looking at the orders in 2021. And there we can see 2021, and we've just got the data that we asked for, so it was quite a quick load. Now we can also work with SQL, so let's take a look at what we need to do to add some SQL codes. First of all, we're going to create a table, and for that we need to df.write.format delta, and then we're saving as table sales orders. Right, so, and we're using spark.sql to add a description down here of the table once it's published. And now we need to refresh our tables. So let's see what we've got. So we've got sales so far, and when we refresh the tables, there we go. So that's the table that we just created, sales orders, and here's the description of the table. So the next cell that we're going to be adding is where we're going to load the data. Now within the learn exercise, we've just got your lakehouse here. That misses any schema that you've got present as well. So you want to add your lakehouse name, and it will do an autocomplete for you. Dot and then it'll start looking towards your, well, it should start looking towards your schema, and then we've got sales orders there. So let's load that. So we have our sales orders, we've got a table, and we've brought that back into the notebook. Now, SQL code on its own in a cell, as previously mentioned, we'll need to use a magic for that. And this is a magic, so %% SQL, and it's just defining what language we're going to use in the cell. So we have this statement here. Let's see. So we want to grab it from sales orders, and then we're grouping by order date, and we've got gross revenue here, and of course we can tidy this up if we want by just adding a bit of basic SQL there, and we can round off the gross revenue for a bit of a nicer presentation. Now we want to move on to visualizing the data. So we have, so we can start viewing the data here. So again, we're going to use SQL, and we're going to view from sales orders, and we're just selecting everything from there. So we have sales orders, and now within this, we can add a new chart, and it'll automatically give us this bar chart, but we can, let me just move myself over here. We can build our own, and here we can add a title. So item quantity, and then how many items do we have? So that's our title and subtitle added. Now in the x-axis, we can add the item, and in the y-axis we can add the quantity, and that'll give us a nice looking bar chart that we can just demonstrate very quickly some results from the table, and we can leave the series group blank, and the aggregation is currently sum, but we do have choices there. We can show averages, min, max, count, first and last, and we can display the missing and null values as 0 or remove them completely. So that's all well and good. We have some basic visualization tools within the notebook, but if we want to get a bit more advanced with it, we'll have to start using external libraries like matplotlib. And the next bit of code that we're adding will look towards, so we'll add a SQL query, and we'll show that. And you can see we've just got a very basic bit of information here, but we want to demonstrate that using one of these external libraries. So let's add matplotlib. And we're going to be importing pyplot, and the first thing you'll notice is that we need to convert the Spark df to pandas in order to get this done. And then we've just got some basic information here. So we're going to create a bar plot of revenue by year, and then we're going to display the plot. So plt.show. And then you can see we've got a nicer looking bar chart than we've previously had, but this allows quite a bit of customization. So next we want to add some of those customizations here. So underneath, we're going to be customizing the chart by plt.title, and then we're going to add a title.xlabel, add the label year, Y label, revenue, and then we're going to give it some color and just a bit more information there. So if we run that, you can see that it looks a bit better, a bit more informative, and we've got our reference lines as well. So the next, we're going to swap out that customization, and let's see what we've got. So here we have we've added create a figure, so plt.figure, and then we've added the figure size. So we've reduced the screen size for that chart, and we've also changed the color. And the next bit we're going to do is add this code, and let's run that. And there we've added a pie chart as well. So we've got create a pie chart, and we've got .py, DF sales, yearly counts, and set title. And we've produced some decent visuals directly within the notebook. There's another library that we can use, which is the Seaborn library, and this kind of simplifies what Matplotlib's doing. So there's a lot more code involved in Matplotlib. With Seaborn, we can get similar results with very brief statements, and we're looking at sns.barplot. And there we go. We've got a colourful bar chart that demonstrates exactly what we need. And if we want to add a visual theme for that, so if we just add it underneath, clear the plot area, we've got set the visual theme, which is sns.setTheme and style white grid. Let's see what happens there. So it's kind of dulled down the colours a bit and given it a grid in the background. And then the last bit of code that we need to do is we're going to change that from a bar chart to a line chart. And let's get rid of these two and paste that. And there you can see we've got, so we've imported the library as SNS, we've got sns.lineplot, and then we've just said on the x-axis give it order year, on the y-axis gross revenue, and get the data from DF sales. So there you have it. A lot that you can do with notebooks. A lot of people will want to use the data flows as it's quite a visual experience, but there's so much more that you can do with notebooks. As I say, I'll add the basics for Pyspark in the description, and use Copilot. Get familiar with it, and there's so much that you can do when it comes to the data transformation and the data ingestion. Notebooks are second to none. So thank you very much for taking part in this module. I hope you found it useful, and stay tuned for module 4. So next we'll be looking at Delta Lake tables. So subscribe for more content, comment below, and give me a like. Okay, thanks very much. Thanks for watching. Bye.